Okay, guys, so this is problem 2 of homework 5. You can try attempting it on your own, and then we can attempt it together. I'll give you guys a minute, और उसके बाद we can start. Okay, so suppose that each child born to a couple. I'm sorry, there's a lot of noise outside my room. I'll just wait a second for it to go down. Okay, so suppose that each child born to a couple is equally likely to be a boy or a girl. So the probability of being a boy or the probability of being a girl is 0.5 and it's independent. It's independently of the sex distribution of the other children in the family. For a couple having 5 children, compute the probability of the following events. First is that all the children are of the same sex. So it can be that all the children are girls or all the children are boys. Sorry. Yeah. So because they have 5 children and everyone can independently be a boy or a girl. So this can be our probability of being a boy and raised to the power 5 because 5 children, and then similarly probability of being a girl. Okay, so the answer should be 1/16. For part B, the 3 eldest are boys and the others are girls. Okay, so 0.5, the probability of being a boy. So we know, let's say ye are the 3 eldest. So this is a boy. This is also a boy, and this is also a boy. And the other 2 are girls. So it's 0.5 for the girl. And again, 0.5. This is girl. And again, girl. अच्छा इसमें you don't have to rearrange or something because उन्होंने बता दिया है कि 3 eldest are the boys. So this is how we'll go about it. And our answer will be 1/32. Part C says that exactly 3 are boys. Okay, so now we can choose. Okay, maybe it's the eldest 3 who are the boys, or the youngest 3 who are the boys, or any 3 can be the boys. So, but it should only be 3 boys. So out of the 5 children, we choose 3 to be boys. The probability of being a boy is 0.5. So raised to the power 3, and then the other 2 can be girls. So girls की probability we know 0.5 है. We square it for the other 2, and answer should come out to be 5/16. Okay. Part D. It says the two oldest are girls. तो अब उन्होंने बता दिया है कि oldest two जो हैं वो girls हैं. So that probability is 0.5 into 0.5. The other three can be anything, but हमको सिर्फ probability चाहिए of the event that the two oldest are girls. So it should be 1/4. Then we have the event that there is at least one girl. That's E. At least one girl means we can subtract the probability of all being boys from the total probability, that is 1. 1 minus probability that all 5 are boys. So this is 1 minus 0.5 raised to the power 5. And it should give us 31/32. Okay guys, so part D में, some of you might be confused कि the two oldest are girls में we have just squared 0.5 and बाकी बच्चों को we haven't taken into consideration. But if you work this out, I'll just do it here थोड़ा सा. So it can be कि 0.5 into 0.5 कि the eldest two are girls, and then the other three can be boy, boy, and boy, or it can be girl, 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 or it can be boy, girl, girl, or boy, boy, and girl. So and then ye do we can rearrange. So 3 factorial over 2 factorial, which will just be 3. And then again 3 factorial over 2 factorial, which is again 3. And probability हमें पता है कि boy होने की या girl होने की 0.5 है. So in each of these 4, our answer will be 0.5 raised to the power 5 for first option. Then again for the second option. Then for the third and the fourth option, it's 0.5 raised to the power 5 into 3 plus 0.5 for the fourth option raised to the power 5 into 3. So इसमें if we take 0.5 raised to the power 5 common, we get 1 plus 1 plus 3 plus 3, which is 8. And 0.5 raised to the power 5 is 1/32, as we saw in part B. This into 8 just gives us 1/4, which is our answer for D. So yeah, you can do this also if you want to see all the combinations. Moving on to the next question. We have question number 8 from the homework set. I'll again give you guys a minute and then we can do it together. Okay, so a factory in China started making balls for ballpoint pen tips in order to improve skipping of the pens. It was found that exactly 30% of the balls failed to improve skipping. So failed to improve skipping 0.3. 10 of the balls are chosen at random. N is 10 to be examined. Find the probability that fewer than 3 fail the test. Acha, we'll use binomial, independent trials n, which is 10, and then probability of failure and success is also fixed, 0.3 for failure in this case, and then for success, improve ho gaya tha, it's 0.7, since they should add up to 1. So out of the 10, fewer than 3 failed. So either 0 failed or 1 failed. यहाँ पे F कर देते हैं. Then 2 failed. So we have 10C 0, 0.30, and then all we had success in sub 10 samples. So this is for 0, and then for 1 we have 10C1, 0.3 raised to the power 1, and then 0.7 raised to the power 9. And then for 2 we again have 10C2, 0.3 raised to the power 2, and then 0.7 raised to the power 8. This should give us 0.3828. Okay, for part B, more than 7 failed the test. Okay, so x is greater than 7. So x is either 8 or 9 or 10. So again, using binomial, we know कि 10 में से choosing 8, probability of failure 0.3 raised to the power 8, and then 0.7 raised to the power 2. This is the probability that out of the 10, 8 failed. Then again, we do the same thing for 9. And our answer should come out to be 0.00159. Okay, moving on. The next question is problem 9 from the homework. I'll again give you guys a minute, and then uske baad we can do it together. Okay, so a parallel system functions whenever at least one of its component work. तो अगर एक भी component काम करेगा, it will work. Consider a parallel system of n components, and suppose that each component works with a probability 0.5. Find the conditional probability that component 1, the first component, works given that the system is functioning. So first component works given that the system is functioning. So इसके लिए we have to do the intersection of functioning and the first component working, which should be 1. Second, and then, sorry, yeah, functioning. Okay, the system, पहले ये हम निकाल लेते हैं the denominator. So the system will function if at least one component is working. So this can be the probability. Total में से अगर हम minus करें कि system function ही नहीं कर रहा है, so not functioning, which means none, like एक भी component जो है, कोई एक component भी काम नहीं कर रहा, it means that. So out of the n components, none of them is working. So अगर working की probability 0.5 है, non-working की भी 0.5 है, so it should add up to 1. And then n, none of the components are working, so all n are not working. So this will give us our answer, which should be, let's just write it in the, because हमें n पता नहीं है कि क्या है, so this is the probability of functioning. And then for the numerator, we can have probability that first component is working. This is given कि first component is working, so the system is functioning into the probability that the first component is working, because हमको पता है कि this will, if we solve for it, it will just give us the intersection. So the probability, given that the first component is working, the probability that the system is functioning is 1. Because this is what I was trying to say pehle, and I think I said it wrong, but I'm not sure. So yeah, अगर first component काम कर रहा है तो 100% system function कर रहा है, because we just need at least one of the components to work for the system to work. And then the probability that the first component is working is just 0.5, because कोई से भी component की probability of working independently 0.5 as the question states. So half into 1 is just half. This is our numerator. So going back, we get half divided by the probability of functioning, which is 1 minus half raised to the power n. And this should be our answer. Moving on, we have this question. Again, I'll give you guys a minute and then we'll attempt it together. Okay, so a data packet of 980 bytes where 1 byte is equal to 8 bits is transmitted over a Wi-Fi communication link. The error rate defined as the probability of any bit to be in error independently over the link is, so let's do probability E 10 raised to the power minus 4. Okay, and 980 bytes हैं, so let's just convert it into bits for our convenience. अगर 8 byte is 8 bits, so 980 bytes is 980 into 8, which should be 7840. Okay. So the question is, what is the probability that the data packet will get through without any error? So means कि किसी भी byte में कोई error नहीं है. Sorry, किसी भी bit में कोई error नहीं है. So the probability of not having an error should be 1 minus probability of having an error. Should be 1 minus 10 raised to the power minus 4. And it's for every bit because we want 0 error. कोई भी error नहीं है. So this is raised to the power 980 into 8. वो जो हम निकाल चुके हैं ऊपर. So it's just 1 minus 10 raised to the power minus 4, 7840. This should come out to be 0.4566. For part B, it says find the probability that the packet contains 3 or more errors. So errors are 3 or greater. It's saying that 1 minus 0 errors or 1 error or 2 errors. तो इसके लिए we can again for 0 errors we know हमने अभी ऊपर निकाला है, it's 1 minus 10 raised to the power minus 4 power 7840. And then for 1 error out of the 7840 bits, choose 1. The probability of error is 10 raised to the power minus 4 raised to the power 1, and then 1 minus 10 raised to the power minus 4 for the other 7839 bits. And then for 2 errors, we have 7840, choose true. The probability of error for a bit raised to the power 2. And then 1 minus 10 raised to the power minus 4 for the other 7838 bits. And this should come out to be 0.04514. And moving on, this is the last question for this tutorial, I think. Yeah, question number 15. I think ये थोड़ा सा बड़ा सा है, and I'll give you guys a minute, and then उसके बाद we can attempt it together. Okay, so a woman has 50% chance of carrying hemophilia. She has two sons. If she is a carrier, let's say, given that she is a carrier, each son independently has 0.5 probability of having the disease. If she is not a carrier, then her sons will independently be normal, will not have the disease. ठीक है. What is the probability that the first son is normal? यानी कि does not have the disease. Or we can just say normal के लिए n. And normal for the first son. Let's do this here. यहाँ पे ना for, okay, let's just put an I here for denoting के is it son 1 or son 2. So abhi we have the probability that the first son is normal. So the first son can be normal in two cases. One, that the woman is a carrier, but the son is still normal. And then he can also be normal given that the woman is not a carrier. तो we know कि ये तो हमारे पास cases हैं जिसमें the first son can be normal. Okay, so we know the probability that a woman is a carrier is 0. Okay, here it is written a woman has 50% chance of. So this is 0.5, and then again she's not a carrier is 0.5. So this we know is 0.5. And the probability that the son does not have the disease given that the mother is a carrier is 0.5. And this we know from, is it written here or did I not tell? Okay, let's just make a tree so that it's easier for everyone to follow. The probability है कि women is a carrier or she's not a carrier. This is 0.5, 0.5. If she's a carrier, sorry, so उसके children में they can either be normal or they can also have the disease. Same is the case here. If she is not a carrier, the children can be normal or they can still have the disease. So this we know if she's a carrier, then 0.5 probability of having the disease. And if she is a carrier, then 0.5 is the probability of being normal for the son. And there needs to be for if she is not a carrier, then her sons will independently be normal. Okay, so they won't have the disease. अगर वो carrier नहीं है, तो there's only one branch and the probability of them being normal when she is not a carrier is 1. ठीक है? And now we're going to use this tree and go back to our problem. Say it. The probability that she's not a carrier is 0.5 and the probability that the son is normal when she's not a carrier is 1 as mentioned here and as shown in our tree. So computing that we get 0.5 square plus 0.5, which should come out to be 0.75. Part B. What is the probability that the second son is normal? Acha, the probability the second son is normal is the same as the probability first son is normal because these are both independent, because we did see यहाँ पे they mentioned it for both cases. Each son is independently having a probability 0.5 of having the disease if she is a carrier, and then being normal if she is not a carrier नीचे वाली line में. So these two probabilities are same. So our answer should again be 0.75. So now we have two probabilities कि sun 1 normal है 0.75 and sun 2 normal है is again 0.75. Part C says, if the first sun is normal, what is the probability that the second sun is also normal? We'll use our rule के intersection and then the probability of the first sun being normal. ये तो we know अभी हमने ऊपर compute करा कि the probability of first sun being normal is 0.75. Now the probability of both of the children being normal. इसके लिए we will compute the probability in two cases when one woman is a carrier and then other when she is not the carrier. अच्छा इसमें wait, let me just let's go with red. If it was red तो I'm sorry पता नहीं why I changed the color. Okay, so इसमें we should know कि ये जो हमें ऊपर बताया हुआ है ना independently, this is not कि you can't just assume कि status जो है of the disease of any of the sons is independent of that of the first or the second जो भी ये conditionally independent है, unconditionally independent नहीं है, because इन्होंने हमें बोला हुआ है given that like women is a carrier, उसके बाद we know कि independently ये probability of having the disease, and then given कि she is not a carrier, then independently, so it's not unconditional independence. ठीक है, that's why the both son being normal, we have to consider the case where one the woman is a carrier and then other where the woman is not a carrier. So हम intersection को ऐसे भी लग सकते हैं. I think you guys know that, but okay. So the probability that both of them are normal given that the woman is a carrier plus the probability both of them are normal given that woman is not a carrier. So we have 0.5 into 0.5 into 0.5. And I'll explain कि कहाँ से आ रहे हैं हमारे पास ये सारे 0.5s. And we have 1 into 1 into 0.5. ठीक है. So first we have the probability कि ये वाली कहाँ है pen? Both of the sons are normal given that the woman is a carrier. So given that the woman is a carrier, this 0.5 is the probability that she's a carrier, and then when she's a carrier, हम tree के इस branch में आ गए, the probability of one son being normal is 0.5, and then the probability of other also being normal is again 0.5. तो इसलिए we have 0.5 into 0.5. ठीक है? Then we add the probability of both sons being normal given that the woman does not have a disease, like she is not a carrier. So the probability of her not being a carrier is 0.5 जो हमने यहाँ पे देखा हुआ है, and अब हमें पता है कि वो carrier नहीं है, तो 100% the son, like यहाँ पे n है, but if for first son be the probability of not having the disease is 100% because the mother is not a carrier, and then again for the second kid same, so that's why it's 1 into 1, and our answer should come out to be 5/8. अभी हमारे पास न्यूमरेटर आ गया, डिनोमिनेटर 0.75 था, तो we just do 5 divided by 8 over 0.75 for this, and our answer should be 5/6. Then we have part D. Part D mein, what does it say? Sorry. If both sons are normal, what is the probability that she is a carrier? Okay, अब हमें given है कि both sons are normal. We want the intersection of this, and denominator में we want this. तो ये denominator हमने अभी ऊपर भी compute किया है, so we don't have to do it again. We know it's this 5/8, and इसके लिए for the numerator we can use the base rule, and this we can also get from ये वाली probability जो है अभी हमने ऊपर भी निकाली हुई थी, like part n1 n2 का part थी, so let's go with purple. Yeah, this probability right here is the same as this right here, so we had 0.5 into 0.5 into 0.5. So our answer should be 0.5 cube over 5/8, which should come out to be 1/5. And now moving on for the last part, I think. If both sons are normal and there is a third son, what is the probability that he will have hemophilia? ठीक है. The third son is not normal, he has the disease, so let's do D for the disease and 3 because the third son, and then we know कि हमें given है कि n1 and 2, the first two sons are normal, so we need the intersection of and read, I'm sorry. Yeah, so we need D3, N1, N2 का intersection, and denominator में we need N1, N2. And denominator तो हमने already compute कर लिया था ऊपर. It was as यहाँ पे भी लिखा है 5/8. Okay, so we need the probability के intersection of this one. This can happen in two cases. First case है कि the women, the mom is the carrier, and then the second case is कि the mom is not a carrier. So it can be N1, N2, T3. The first two sons are normal, but the third son has the disease. Given that the mother is a carrier, into the probability that the mother is a carrier, plus again the first two sons are normal, the third son has the disease, given that the mother is not a carrier. So this comes out to be 0.5 plus 1 into 1 into 0 and then 0.5. And this I'll just explain in a minute. I'm just calculating pehle and then I'll tell you how we got here. Should come out to be 1/16. Okay, so इसमें first is the first two sons are normal, the third son has the disease given that the woman is a carrier. So this is the probability of women being the carrier, and this is the probability कि पहले दो sons जो हैं वो normal हैं, but the third son has the disease. This we can go and see in the tree. Okay, if the woman is a carrier, the probability of any of the sons being normal is 0.5, and any of the sons having the disease is 0.5. So following it from here, the first two sons are normal, 0.5, 0.5, and then the third son has the disease is 0.5. Now, the probability that the woman is not a carrier is again 0.5. And when she is not a carrier, वापस tree पे आते हैं, then the probability of the son, any of the son being normal is 1, 100% normal होगा, and the probability of any of the son having a disease probability is obviously 0. So going back here, probability son 1 is normal, son 2 is normal, and then the probability that the third son has the disease is 0 because the woman is not a carrier. तो जब हम उस tree में women is not a carrier वाले branch पे enter करते हैं, उसके बाद the son having the disease की probability is 0. So that's how we got this. And then we compute the values in the numerator and denominator. 1/16 divided by 5/8 should give us 1/10. Yes. And this is our answer. And this is all for today's tutorial.